right. So for those of you who are frequent attendees of Astronomy on Tap, you must all be very familiar with this picture by now. So this is a very pretty, nice sky that you probably won't be able to see in Austin. But you can recognize our Milky Way from this dark filamentary structure. And you can probably also recognize our dear neighbor galaxy, Andromeda. This is one of the 3 galaxies that we can see with our naked eye, other than our Milky Way, of course. But you may be less familiar with this picture. This is the night sky we will see about 4 billion years from now, if we are still around. So it took decades of observations for astronomers to figure out exactly the speed and trajectory for how our Milky Way and Andromeda are approaching each other. And it turns out that in about 4 billion years, our Milky Way will have a head-on collision with Andromeda. And within the next couple 100 million years following that collision, the strong gravitational pull between our Milky Way and Andromeda will completely torn apart both of our nice spiral structure. But in return, we will get an even prettier night sky to look at. Isn't that nice? So fortunately, we don't need to wait 4 billion years to see such a spectacular event. If we look beyond our neighbors and use telescopes like Hubble Space Telescope, we can actually see examples of these colliding galaxies. And these colliding galaxies have all sorts of different structures. So some of them, we can still separate out the 2 galaxies, like these guys up here. We can tell there are 2 galaxies are colliding with each other. But in the others, we can't even tell there were 2 galaxies, like these guys right here. And the only reason we know they are colliding galaxies is because we see they have this kind of really extended and distorted structure, and that a single galaxy just cannot produce on their own. So why do we see this huge variety of structures in these colliding galaxies? Well, astronomers have been running simulations of galaxy collisions on computers. And it turns out colliding galaxies change the way they look during the process of interaction and merging. Before the 2 galaxies even come together, their structures are largely undistorted. But things start to get messier once the 2 galaxies pass each other for the first time. And because galaxies are extended, so the material that's fall on the one side of the galaxy will feel slightly different gravity compared to the material on the other side of the galaxy. And that's the same reason we have tides here on Earth. And this can cause the material like the stars and the gas fall on the far side of the galaxy being tossed out from this merging process. And this galaxy can develop this really, really large distorted structure. And we can see this structure all the way until the 2 galaxies finally merge into one. So there are many, many exciting things can happen during this merging process, especially when the 2 galaxies have about the same sizes, like our Milky Way and Andromeda. So for a galaxy like our Milky Way, even if we just sit around and do nothing, each year there will still be about 1 solar mass worth of the new young baby stars being formed. But for galaxy mergers, for some of these galaxy mergers, each year they can produce young baby stars at a rate that's 10s or 100s times higher compared to our Milky Way galaxy. And it's because during this merging process, a lot of the material, like gas, can be funneled toward to the center of the merger. And this gas can quickly cool down and produce enormous amount of stars. And this gas that's being funneled to the center of the galaxy mergers, they can also be used to feed the supermassive black hole. And some of these black holes, they are so active that they can launch extremely bright and powerful jets. And remember those material got tossed out from the galaxies? So sometimes small baby galaxies can form from this extended gas stream of the larger galaxy. So although so many exciting things can happen during the galaxy collision, an important question we must ask, though, that's also driving my own research, is how often do galaxies collide? When we are building like a model or theory for the life story of a galaxy, we must ask how important is galaxy mergers? Are they important enough that we need to take them into account? If, say, the galaxies almost never collide, then maybe we can just forget about these galaxy mergers and I can probably just stop talking now. But if they do happen more often, then maybe we need to give these mergers some more thoughts. So at present day, there's only about 1% of the galaxies are colliding. So maybe you will say, okay, maybe we can just forget about these mergers and just move on. Well, except there might be more of them in the early universe. Remember, our universe was a lot smaller in the past. That means galaxies were much closer to each other. So perhaps the chances of a galaxy to interact or colliding into another galaxy would be much higher in the early universe. But how can we test this hypothesis? Well, we can go and look at galaxies in the Hubble Ultra Deep Field, which Professor Ridiculous will tell us more later, and see how many of these distant and young galaxies, how many of them are colliding galaxies. And indeed, we see a bunch of these galaxies, they have this really extended, distorted structure. And they look just like the galaxy merger and colliding galaxies we've seen before. But the problem is, though, because these galaxies are much further away. That means they are much fainter. And it makes it exceedingly difficult to tell whether some of these galaxies are colliding galaxies or not. And this actually matters a lot when we try to ask this question, how often do galaxies collide in the past? Depending on the exact method we use to classify this distant galaxy, someone may say, well, there's a little bit more of galaxy mergers in the past. But the other may find much more of them in the early universe and reach a completely different conclusion. So more recently, astronomers has been thinking about maybe there's a different way or additional way that we can use to classify these distant galaxies and to tell whether they are colliding galaxies. So we've been looking at a lot of these images of galaxies. And this tells us how the light that's come from a galaxy distributes on the sky. But we can also look at how the galaxy light distributes as a function of wavelength. And this is called a galaxy spectrum. And a great technology that combines these two capabilities is called an integral field spectrograph, or an IFU. What IFU gives us is the galaxy structure as a function of wavelength. So when we observe a set of line features from the galaxy spectrum, that helps us to figure out whether these lines have been redshifted or blue shifted. And that tells us whether the objects are moving away from us or moving towards us. And in an IFU observation, we can get a spectra at each position of the galaxy so that we can figure out the motion of these galaxies. And for a rotating galaxy like our Milky Way, we will see a velocity map that looks something like this. And it's because one side of the galaxy is moving towards us, so the spectra is blue shifted, but the other side is moving away from us, so the spectra is red shifted. So if we see the velocity map, this kind of rotation pattern in the velocity maps, maybe we can say these galaxies, they are not interacting or colliding with another galaxy. But a more complicated velocity map would definitely be a telltale sign of galaxy mergers. And in the past couple years, tremendous progress has been made to get the velocity maps of many hundreds of these distant galaxies. And each of the figures you see on this plot is the velocity map of a distant galaxy. And with this velocity map of so many hundreds of distant galaxies, we're hoping to get a more precise answer about how frequent do galaxies merge and collide as a function of cosmic time. And to really get a concrete answer on the importance of galaxy collision in the life story of galaxy. Thank you.
All right, thank you, Merger Maniac. Let's start with a quick question from Twitter. And one of your slides, you had NGC and VCC. What does that mean?
That's just the name of the galaxies, the catalog, the name of the
Yeah, astronomers have bad naming conventions, so sorry about that. All right, let's take some questions in the back. Yes, you, right there.
Oh, so the question is, what is the difference between the brown and the blue? So this is just like an illustration, and so like if you the x-axis, the bottom one is like the cosmic time, and my direction is like very distant universe, very distant in the past, and that's the present the universe. That's where we are right now. And so what this blue and brown are plotting is like how many merger or how many colliding galaxies as a function of time. So in the case of the brown one, there would be much more colliding galaxies in the early universe compared to the blue line. And this is just the illustration of like what might be possible, what's being observed and what might be the possible answer.
Okay, we're going to go up front early. There we go.
Galaxies who collide are going to merge? Is it 100%? Do they sometimes collide through each other and keep going on forever?
Yeah, so there's definitely some cases that like there's a lot of like free parameter you can put in like in these two like merging galaxies. Like for example, if they are moving towards each other in a very fast speed, then they may just like fly by each other. And like they won't necessarily like come together and merge into one. But for the galaxies I'm talking about in this talk, like we all assume like they will eventually come together and merge into one. And that's how you will see this kind of very exciting event happening in these cases.
Okay, upper deck, you gotta yell.
So the question is, why do they collide? Yes, I think you answer your own question. Yes, it's gravity.
So why don't they end up just orbiting? Why don't they end up just orbiting each other?
Well, because when the two galaxies collide, like actually like a lot of things will happen. Like for example, like a lot of the you can say the gravitational energy would go into like for example like gas and stars or the dark matter. And therefore they lose their gravitational energy and therefore they will come into one in the end.
Okay, in the back, sir.
Milky Way had gone underground. Well, so if you are counting like the interaction with not necessarily a galaxy like Andromeda, it actually could happen pretty often. Like for example, our Milky Way is interacting with LMC and SMC, like those much smaller galaxies. But in those cases, like you won't see like Milky Way property being dramatically changed.
All right, right up front.
In your talk, you mentioned mostly galaxy versus galaxy. All is galaxy versus more galaxies, let's say 3 or 4 galaxies.
Can you, sorry,
Say that one more time.
repeat your question again?
In your talk, you mostly talked about 2 galaxies.
Yeah.
How would this change if, let's say, 3 or more galaxies?
So the question is what will happen if there are not only 2 galaxies but actually much more like 3 galaxies merging? Yes, we do see they are very rare. They are about maybe like if we say like 1% of the current galaxies are merging at present day, there's only like 100 times less of like 3 galaxies come together, for example. And usually what happens is if they will finally merge, like for example, the stars as young stars being formed would be even more compared to the 2 galaxy merging into one case.
Okay, in the back again, the hat. So if the cores of the galaxies are actually colliding, why does that work with binary stars? How do binary stars end up?
Binary stars.
Why don't the black holes of the galaxies orbit each other in the end?
Again, like they're when the 2 black holes come together, like there's like a lot of material like let's say like surrounded this black hole, and those material will keep like taking away the energy, and therefore like in the end the you can think of like the black hole will lose those energy, and so they have to come together. And so earlier about the binary star, I'm not sure what happened with. I don't know if specifically like maybe some of them would get destroyed, but yeah, I'm not sure.
Okay, one more question. All right, in the back with the wavy hand.
Right. So the question is like if our say our universe is expanding, then the galaxies are moving away from each other. Then why would they collide? So that's that's a good question. And I think the answer is just like what scale you are talking about. Like at the scale that's like maybe 100 times like larger than say the distance between our Andromeda and Milky Way. And yes, like the galaxy largely won't feel each other, the gravity from each other, but like on the smaller scale, like gravity is still the dominant force.
Okay, let's thank Measure Maniac one more time.
Thank you.
Great, thank you.